The angle on angles. Today we're going to go over the definition of an angle, look at the component parts of an angle, and classify different types of angles according to their measure. An angle is essentially composed of two rays that are joined together at a common endpoint. Here we have rays BA and BC. If we join these two rays together at a common endpoint, in this case point B, we have an angle. The joining point of an angle is called a vertex. The two component side rays are called arms. Angles are labeled in different ways. One common way is to name the angle after the point at its vertex. This angle could be labeled angle B after its vertex at point B. When there's a number of angles on a drawing that share a common vertex, it's not practical to name an angle after a vertex. It's not descriptive enough. For instance, in this drawing, if you describe angle B, it could be one of two angles, since B is the vertex of two different angles. Therefore, an angle can be named by 3 points, one point from each arm with the vertex point being in the middle. For example, the angle on top could be called angle ABC or angle CBA. The order doesn't matter as long as the vertex is the point in the middle, in this case point B. The angle at the bottom can be labeled angle CBD or angle DBC. And I almost forgot, there's even one more angle in this drawing. The two angles together, the top and bottom, made a third, bigger composite angle as well, and that would be angle ABD or angle BDA. An angle can also be named after a Greek letter, usually located in the center area of the angle. This, for instance, is angle beta, and beta is the Greek letter for B. Angles have measures. In math, we can measure in radians, but most often degrees are used because that's the most common usage in everyday life. Degrees can be further split into minutes and seconds, but degrees are what we'll be using today and for most of life. A protractor is a tool that can measure angles. The center of the protractor is placed at the vertex of the angle, and the straight edge lines up on one of the arms of the angle. The protractor measures angle ABC here at 50 degrees. Angles have different categories of names depending on their measures, and we'll use our protractor to classify them and measure them. Angle ABC here is just a small sliver of an angle, about 1 degree. Angles can be measured even smaller than 1 degree. Here, angle ABC is a 30-degree angle. This angle has special meaning in a triangle as the ratio of sides. This is a 45-degree angle. It has the unique characteristic of being exactly halfway between an angle of 0 degrees and 90 degrees, and is very important in geometry when evaluating dimensions and relations of diagonals across squares. 45 degrees is the optimal trajectory for aiming projectiles for maximum distance. Here, angle ABC measures 60 degrees. It, like a 30-degree angle, makes for special properties in a 30, 60, 90 triangle. It's also the measure of an angle in an equilateral triangle. All angles up to 90 degrees, including this one at 89 degrees, are classified as acute angles. All the angles we've measured thus far are acute angles. Angles that measure 90 degrees have their own special classification, right angles. This angle has significant properties. There is a whole large branch of mathematics, trigonometry, that is based entirely on the ratio of sides to each other in right triangles. Right angles are customarily noted by a little square at the inside of the vertex between the arms. Angles measuring greater than 90 degrees but less than 180 degrees are classified as obtuse angles. And this obtuse angle appears to measure about 115 degrees, 116 degrees. A straight angle is really a line. You continue the rotation and those two rays go in opposite directions, and it measures 180 degrees, and since it is two rays going in opposite directions, it really is a line. An angle measuring greater than 180 degrees is called a reflex angle. To measure a reflex angle with a regular protractor, measure the angle of the short wave, subtract it from 180 degrees, then add 180 degrees. We won't measure, but this reflex angle looks to be about 15 degrees past a straight angle for about 195 degrees total. The last one we'll look at today is called a full rotation angle, or 360 degrees, where the one ray has rotated entirely around a full circle. I drew a bit of wobbly spiral here, but I hope you get the idea. This reminds me of the time I tried to do 360s on my student skateboards in my classroom. One of the students took a video of me when I was doing it, and I fell down. These angular relationships are very important in geometry. Every angle, no matter its measure, has a proportion to a full circle, or 360 degrees. If you see that an angle is 1/3 of a circle, you know that its measure is 1/3 times 360 degrees, or 120 degrees. This principle of proportion can be used to find the length of an arc of a circle, or the area of the sector of a circle, by making them a proportion of a full circle, or 360 degrees. This has been The Angle on Angles. Thanks for viewing.